Okay, this is number 51. It looks like we have a cubic polynomial graph given for my f of x function, and f is labeled on the graph, so I don't really need to put this f of x up there. I could, but it might get in the way. So anyway, the f is there. Okay, so we're going to use our chart for help. Again, we'll start with where is the original function increasing versus decreasing. So it looks like we are increasing from negative infinity to some decimal about here. Then we are decreasing till about here, and then we're increasing again. Now, I'm looking at increasing and decreasing because that tells me where my derivative function is going to be positive versus negative. If this is a cubic function, x to the third power, then my derivative is going to be a quadratic. So it would make sense that my derivative graph could be positive, then negative, then positive. So it could look something like, let's see, we'll have relative extrema, where we have relative extrema on the original function. We're going to have zeros, or undefined values, but in this case zeros because we're working with polynomials on my derivative curve. Maybe if I make those blue, we can distinguish between the original and the derivative. So my derivative curve could look something, like this, where it's a quadratic and it comes down. Really bad drawing with a mouse, and then comes back up. We will try to draw something like that. All right, just for reference, if you didn't use it last time, I'm looking at this right now. So I'm kind of going through my chart and saying, and looking to see what I know. Where my original function is increasing, my derivative is going to be positive. Where my original function is decreasing, my derivative is going to be negative. Okay, so I have the increasing, decreasing, increasing on the original function. That means I'm going to have positive, negative, positive values for my derivative function. I also have extrema on the original function. So in this case, my derivative is going to be 0 at those points. I can also look at my graph and I can see that I have an inflection point right below really where the f is. And so if I draw a line through that inflection point, just for a boundary sake, I can say that to the left of that line, so from negative infinity and to this point on f, my graph is concave down. From that point to positive infinity, my graph is concave up. So that tells me that my derivative we'll just say y prime for quick sake. We'll make it look better than that. Okay, so for my concave up, that means my derivative is increasing. For concave down, that means my derivative is decreasing. So again, that goes with the quadratic idea. And here, okay, my original is concave up on the right-hand side, so my derivative is increasing. My original is concave down on the left, my derivative is decreasing. That inflection point that I see is going to be an extrema on the derivative curve. So I'm going to have an extrema somewhere. Now I really don't know where this point is going to be as far as vertically goes. I don't know points in the original graph, so I can't come up with the actual equation. So this relative extrema could be kind of anywhere. But then we are going to do our best with my pen not really my pen, my mouse. Do my best to try to draw this curve as a quadratic function for my second derivative. Or no, this is my first derivative. Okay, so the original function is graphed in black. The derivative is graphed in blue. Okay, we can tell that from that red line where the relative min is on the derivative, that the derivative graph is increasing to the right, which follows the concave up from negative infinity to that minimum. It's decreasing, which follows the concave down. But I also want to graph the second derivative now. So everything I did so far was to look at the first derivative. So the second derivative has to do with the concave up and concave down. Okay, or you could look at it as the decreasing and increasing of the derivative. If a function is decreasing, then its derivative is negative. So now we're looking at these values off to the side. So since it's concave down initially, and the derivative is decreasing, I know the second derivative is going to be negative. I know to the right of that red dashed line, because it's concave up, and my derivative is increasing, that my second derivative is positive. So at that relative extrema, I'm going to have a 0 on the second derivative. And I'll put this 0 in red, because we're going to graph our second derivative as a red function. Since my first derivative was a quadratic, my second derivative is going to be some type of linear graph. I don't have arrows on the red line, but you get it. So that's my second derivative function. And again, I don't know how steep it is because I don't know the equations associated with the original function or the derivative. But I know that because the function is concave up to the right of this red dashed line, the derivative is increasing to the right of this red dashed line, then the second derivative is positive to the right of the red dashed line. And then everything to the left is concave down for the original function. The derivative is decreasing. The second derivative is negative. So that's it for 51.